to my YouTube channel. In this video, we are going to see about the linked list data structure. So, what's the objective behind this lecture? So, by doing this lecture, we would be able to get all the knowledge of the linked list data structure, how it is implemented, how we store the data, and how to traverse and how to do the operation on linked list. We will be able to do all this stuff, and we will be in a situation from that we can solve the we can start solving the problem. So let's start. So what is the linked list? Linked list, as the name suggests, the list which are linked to the each other. Okay, so linked list is a linear data structure. Linked list is a linear data structure in which the elements are not stored in continuous memory location. So linked list is a linear data structure, like data stored in the form of in linear manner. Okay, like this, in which elements are not stored in the continuous memory location. Like in the case of the array, what's happened, the elements are stored in the continuous memory location, but here in the case of linked list, the elements are not stored in the continuous memory location, and the elements in the linked list are linked using the pointers. So we see that the each element are linked to the each other by the pointers. Okay, these here arrow are the pointer. Okay, so up to now we are clear up here. So moving to the next slide, how the pictorial representation. So we see that each node, each these structure is known as the node. First node 1, we can say it as node 1, this is node 2, this is node 3, this is node 4, and if the new node will come, we will just we'll keep on adding. So each node, what we see, there are two parts. Like the first part is the data part. Here is the data part, and this part is contain the next part. Okay, so what the next part will contain? Next part will actually contain the address to the next node. So here what will the next in the node A, like first node A, so it will contain the address of the B. What will the next of B will contain? It will contain the address of C. What the next of C will contain? It will contain the address of D. And what the next of D will contain? It will contain null. Like after that there is no other element is present, so we have to stop now. That's why it's containing the null. Okay, so move to the next slide. Why linked list? Like why we are using the linked list? Like there are many other data structure like array, stack, queue, dequeue. There are so many. And why we are using the linked list? We are using the linked list because the size of the array used to be fixed. If we have to insert more than that fixed amount of element, then we have to create another array and we have to insert all the elements accordingly. That would be time consuming and take that would be not memory efficient as well as not as well time efficient. And insertion and deletion, second point is that insertion and deletion of the new element in the existing element in the array is expensive, like more time is required. Okay, so let's see it by the example. Like we have been given a array like 1 2 5 4. Okay, and we have to insert a new element like 7. We have to insert 7 at the third index. Okay, like 0 1 2 3, like here we have to insert. Then what we will do, like we will keep on 1 2, then we have to insert here 7. Okay, so here it will be not, we can not directly insert. Like there are 5 and 4, we have to remove 5 and 4, then we have to insert 7, then again we have to insert 5 and 4. Like this is time consuming. Okay, so up to here we can see here the linked list can be a solution. Like in linked list, suppose this is the linked list, Here it is 1, it is 2, it is 5, it is 4, and we have to insert 7. So what we will do, we will just move 1 to 2, and what we will do, we will just unlink this. We first store the address of this link and we will unlink this, and now we will make the node of the 7, and just we will do next of 2 as 7 and next of 7 as 5, and other will be linked as earlier. So it will make our life easier, like we didn't have to remove the all element, we have to just do one step, like we went to that particular element where we have to insert, after that we unlinked and just link to the next. Okay, so here up to kill you, I think so. Advantage of linked list over that. So what are the advantage? Like we have seen earlier, dynamic array, linked list are linked list can act as dynamic array, like its size can be increased, decreased, or whatever we can do, anything we can do with the size. Ease of insertion and deletion. Insertion and deletion will be taken of one time if we are present at that particular element which have to be inserted or deleted. Like insertion at the beginning, although each constant type we check of one time. Like we have been given elements of the linked list like this, and we have to insert at the beginning. So what we will do, we'll just make a new element, new node, and just we will do the next of this as the head, and head of next will be pointing all the other, just it will be linked in this manner. And we have to insert at the in, then what we will do, we will start with traversing from one node to second node, third node, and so on, and at last node what we will do, we will make another node of the that element which have to be inserted, and we will do next of last element which was earlier null or none to the address of the inserted element. So this will make our problem simpler manner. And what are the disadvantage? So still now we have seen many advantage, but there are disadvantage also. Like random access is not allowed. In the case of the array, we were able to get the random access, like from 0 to n minus 1 we can get any element of the array, but here it is not possible. Like it's are not continuous memory allocation as well as, and they are not indexed. So we have to getting any element, we have to traverse to that element. After that we can only get what the data is actually present, otherwise we can't get. Another disadvantage is that extra memory space for the pointer is required with each element in the list. Okay, so while making the node, we are also storing the address of the next node now. So this taking the extra memory allocation. This is the one of the disadvantage. Like earlier in the array, there was no extra space were required for the storing the memory, like the address of the next, and that is not possible in the linked list over the array by the index. Up to here is the clear. Representation of the linked list. How we can represent the single linked list? So we can represent the singly linked list we have seen earlier. Let's see us again some important terminology. Like the first node is called the head. The first node which will give the first node which will give the uh, like it will give the information about all the node. Like if we will know the address of that node or that node which is known as the head, by that we can get the access to the all the node. Like by traversing through that we can go to the any other node of the list of the linked list. Have the and the last node is known as the tail of the linked list. Each node contains the at least two parts. First is the data part. This is called the data part, and this is called the pointer to the next element. Okay, here to clear. Okay, so how we can represent? We can represent each node. Okay, each node has the in the form of the classes. Like we will make the class here. This is the class. Let's name it the node. Okay, so what we will do, we will make a constructor diff init, and we will pass the data. First one is by default self, which will issue the link, and then the data. Okay, so what we will do, we will initialize the data self dot data with the data, like we have to initialize. Okay, and next, like there is only one element present initially. Whatever the we will generate the node, and that the every initially created node will point to the next to the none. That's why we will do self dot next to the none. Here it's, I think up to there will kill you. So now move to the coding part. Up to here we have seen, like this will create the this will collect the node class. Now we are making the whole linked list class. So linked list class will be collection of nodes. Up to here we have made here up to here. Okay, so here we have made the linked list. Okay, initialize the linked list as the one of the head. Like first one will always will be head. Like we have generated now, like node, we have generated the node. Okay, so we will initialize each as the head. Like each will first will be head. After that we have to insert anyone. We will, what the property it will have, we can insert any element to the linked list. So there will be another functionality like insert, then last functionality will be print linked list. Okay, so now move to the insert part. So what is the logic behind the insert? How we can insert? If the head, if the head is like at the initial point, like if the head is none, like no other elements is present, only single element is present, or none element, like no other element is present, no means each linked list is currently empty. And if we are starting to, we have started the inserting the inserting the node, in that case, like head is none, like no element is present, so we have named that current node as the head. Like we have made the node and we will name it at the head. New node, we have first created the new node. Like whichever node to be inserted, we will give it the data, and the data will convert into the node. Like node class will convert into the in node. So if the help, like head of the head is none, like no element is present, then we will just initialize it as a new node as head. Like no other element is present earlier, so it will be the head. Okay, and like if there are more than 2 or 3 elements or one element, then the current head will be not the desired position where we want to insert. So like this is the head and we have to insert here, so we will traverse up to the here and then insert here. So we are doing same thing here. So we are doing same thing here. Like current we have made self dot head, we will get the head, and we have traversed to the till that position, till that we have not get the none. And at till, and when we get the none, like we get the none, then we have inserted here like current dot next to a new node. This has been clear. I think this will be clear. Moving to the next functionality, which is the print linked list. So how we will print all the linked list? Like if we will get the head, if we have of the head, then what we will do, we will print just the head dot val. Head dot val This will give the data here and just move the head to the next node. So how we can do that? We can do this pointer, let the pointer is current is equal to current dot next. This will do the same thing. So we have get the head and we have started traversing from the head till the none, and we have printed the each of the data. Here too I think it will clear. That's all in this lecture. Another in upcoming lecture we will see by doing coding on some ID and taking some example. We will try to see the how all the things work, and we will see many more interesting questions. Till then, keep watching and keep learning.